We have a method now for multiplying fractions, so top by top, bottom by bottom. So that gives me, 3/8. And as I said, that's like having, where do we get the method from? Well, if I want half of a cake, top by top, bottom by bottom, I end up with a quarter of the cake, which makes sense if I want half of a cake. So these methods don't just come out of nowhere. So now that we have a method for division or multiplication, can we use this maybe as a method for division as well, or some version of it perhaps? So think about it. If you have half a cake and you want to divide it between 4 people, well, logically, if you have half your cake and you want to divide it between 4 people, so 1, 2, 3, 4, how much the full cake now are they getting? Well, they're getting 1/8 of the original full cake. So now how does that work? How is it that a half divided by 4 is equal to 1/8? Well, if we want to use our multiplication method, then division is the same as multiplication, but you have to flip your fraction. So 4 is the same as 4/1, so that flips to a quarter. And then we go top by top, bottom by bottom, and that's how we get the 1/8. So, if we think about it logically, I have, this original cake, and we're looking at, I have half of it, and I want to divide it between 4 people, and I got the answer 1/8. So how did I do that? Well, division is the same as multiplication, but you must flip your second fraction. Now, sometimes you'll hear the word invert. So you could hear like division is equal to invert and multiply. So that is the method. So now we know how to add fractions, subtract fractions. You're multiplying by going top by top, bottom by bottom, and you're dividing your fractions by inverting your fraction and multiplying. That will be the same in algebra now. If we were looking at ones the other day to do with multiplication, and it was top by top, bottom by bottom, you might want to simplify your fraction first and then you do your multiplication. So let's just look at a basic one here. 4x over 8y maybe divided by 2x squared over let's go for 4y cubed. So we don't really have a method for division, let's say, except we're going to invert and multiply. So that's 4x over 8y multiplied by 4y cubed over 2x squared. Now you could just multiply top by top, bottom by bottom, or you could look at simplifying your fractions and then multiplying top by top, bottom by bottom. I'm just going to do I'm just going to multiply and then simplify just for once. Normally I simplify and then I multiply out. So that's 16xy cubed all over 16. Now x squared times a y, I'm going to put them in alphabetical order. So, that's 16 times x times y by y by y. That's what that top line looks like. And that's 16 by x by y. So it's written in its factors now very easily. This is an easy question to simplify. I end up with y squared over x. So 2 fractions to be divided, invert and multiply, and then do what you'd normally do with your algebra. If we went for maybe a little bit of a trickier question, like if we had 3 over x squared minus 9 times x plus, no, sorry. So we're divided by 12 over x plus 3 maybe. So division is the same as inverting your second fraction and multiplying. Before I multiply out, and it doesn't matter, like whatever way you want to do it, but generally before I multiply out, I try and simplify. The only way to simplify is to try and write a fraction in its factors. So 3 is made up of 3 times 1, that's fine. This is made up of, so this is, what type of factorising is this? It's not common factors, so when I look at it, it's the difference to squares. To be multiplied by x plus 3 all over 12 is made up of 3 times 4, whatever way you want to make that up, or 2 times 6, whatever, but I can see my 3's are going to simplify. So top by top, so that's 3 times x plus 3, bottom by bottom. And I can just start simplifying. I end up with, so 1 left on top there, because, you know, 3 times 1, remember, if you want. And then x minus 3 times 4 is 4x minus 12 on the bottom. So that's just your basic division of fractions, invert and multiply.